Hey there guys, we've been working on balancing reaction equations. We started with how to balance reaction equations, and in a separate video demonstration I showed you how to do the example problems, and I got you started on the easy problems. And then after that there are several more sets of problems. There are more problems and harder problems, and you're probably looking for some help with those. So that's what this instructional video is for. Now when you watch the video, I'm going to go very quickly, and the reason is because YouTube videos take a long time to upload and they're limited in size. So I'm going to go really quick, and what you may need to do is just stop and rewind and watch it again, or slow it down, pause and take a break and come back to it if things go by too quickly. So don't get frustrated if it goes by really quickly. Use your common sense and slow it down, stop it, pause it, rewind. It's a video, you're in control. Okay, if you're having difficulty with the problems balancing reaction equations, let's do a few together. In fact, let's do them all together. Working on the assignment More Problems, More Balancing Problems, which you can download from the Moodle site or you can get in class. What we're trying to do is make the same number of atoms in the reactants and in the products, the same number of atoms of each element, by changing coefficients, the numbers that go in front of each compound. On the side of each problem are listed the elements that make up the compounds that are in the reactants and the products, and below each compound or each substance there are lines for counting how many atoms there are in the starting formula. So for example, in the first one there's 1 calcium, and in the parentheses there are oxygen and hydrogen. The subscript outside distributes, making 2 oxygens and 2 hydrogens. Here there are 3 hydrogens, 1 phosphorus, 4 oxygens. Over here there's 1 calcium, 1 hydrogen, 1 phosphorus, and 4 oxygens. And on this side over here I'm going to cover up that coefficient and count 2 hydrogens and 1 oxygen. Now what the coefficient that I covered does is it multiplies everything that's in the formula by 2. So that means the 1 oxygen that I counted is really twice as many, and the 2 hydrogens I counted are really twice as many. I want to check to see first if the reaction equation is balanced now. If I look at the two sides of the problem, the reactant side and the product side, and I count 1 calcium on each side, and I count a total of 6 on the reactant side, and a total of 6 on the product side, a total of 5 hydrogens on the reactant side, and a total of 5 hydrogens on the product side, 1 phosphorus on each side. This one is already balanced because of this subscript right here, this coefficient, the 2. We're trying to figure out what numbers to put up here to multiply the formulas so that the number of atoms of each element is equal on both sides, the reactants and the products. So we don't have to do any more work on that one. Let's try the next one. So the first step, always count how many atoms of each element you have to start with. I'm going to cover up this coefficient and count 1 sodium, 1 oxygen, 1 hydrogen. And then I'll go back and I'll apply that coefficient. This 6 multiplies everything in the formula by 6. And I'll continue. Sodium is 3, arsenic is 1, oxygen is 3, and the hydrogen is 2. Let's check to see if it's already balanced. 1 arsenic, that's good. 6 sodium is 3, nope. 6 and 3, 2 and 2, not working. So we've got to change some coefficients. It's easy to fix this one. If I wanted to have the same number of sodiums in the reactants and in the reactants and in the products, then I would multiply by 2 in the products, because now everything in the formula gets multiplied by 2. Now these 6 sodiums balance, these 6 oxygens balance, the 2 arsenics don't balance. So let me go back and fix that. If I multiply arsenic by 2, now I've got 2 arsenics in the reactants. The 6 hydrogens, they don't balance these 2 in the product side. So if I multiply by 3, then this becomes 6. And now I can look at the two sides of the problem, the two sides separated by the arrows. The arrows point to the products, separating the starting materials from the ending materials. And I see that they're the same number of atoms of each element on both sides. Now this reaction equation is balanced because of these coefficients that multiply the formulas of those compounds. Let's try the third one. Okay, in the third one, we'll start by counting carbon, 2, Hydrogen, there's 5, and then there's one more hanging off the end there to make 6, and then 1 oxygen. The oxygens here, O2, I'll count 2 oxygens, but then I'll apply this coefficient and multiply that by 3 to make 6. Continuing on, the carbon is 1, 2 oxygens. Hydrogen is 2, 1 oxygen. Some things aren't balanced. 2 and 1, 6 and 2. This adds up to 7, and this adds up to 3, so we're not balanced yet. It's always a good idea to start with things that are simple, like 2 and 1. That's easy to fix. If you multiply this carbon dioxide by 2, then everything in the formula gets doubled. And other things start to look like they can be fixed. This 6 and this 2, they don't balance, but if we wanted that to match, we could multiply by 3. Now everything in the formula gets multiplied by 3. And now those match. Let's see what we've got. 2 carbons in the reactants and the products, 6 hydrogens in the reactants and the products, and a total of 7 oxygens in the reactants and in the products. When I say the reactants and the products, I'm splitting the problem up where the arrows are. The arrow divides the reactants that you start with from the products that you end with. Okay, problem number 4. We'll start by counting the atoms of each element, strontium and bromine. And then the next one, the nitrogen, the subscript outside multiplies the nitrogen. There are 2. Hydrogen is 8. 2 times 4 is 8. 1 carbon, 3 oxygens. Divide the reactants from the products just to keep track. 1 strontium, 1 carbon, 3 oxygens. I'm counting these atoms. And then over here for nitrogen, 1 nitrogen, 4 hydrogens, 1 bromine. Look for things that are easy to start with, like 2 and 1, or 2 and 1. We can get that to fix. Let's fix that right here with the bromine. Let's multiply by 2. Then everything here gets multiplied by 2. Now this matches this. Let's see. Is there anything else that needs to be fixed? 1 strontium in the reactants and the products. 2 bromines in the reactants and in the products. 2 nitrogens in the reactants and the products. 8 hydrogen. 1 carbon. 3 oxygens. It's balanced. Same number of atoms of each element on both sides. Alright, moving right along. I'm going to do the next one, number 5. Start by counting how many vanadiums. There are 2, and then 5 oxygens. Hydrogen 1, chlorine 1. Divide the reactants from the products. 1 vanadium, 1 oxygen, and 3 chlorines. And then the water here, I'm going to count 2 hydrogens and 1 oxygen. And then, since there's a 3 coefficient, I'll apply the 3, multiplying everything in the formula by 3, changes that, and changes that. Now, since I know that this is part of the answer, I think I'll start with that, because this 6 is part of the answer given. I'm going to balance that by multiplying by 6 on this side, and then I've got this balanced, but I don't have this balanced. So the 6 chlorines and the 3, let me multiply by 2. When I do that, now those balance. Let's see, 5. Oh, but look at this. 2 vanadiums and 2 vanadiums in the reactants and products. 5 oxygens and 5 oxygens in the products. 6 hydrogens, 6 hydrogens, 6 chlorines, 6 chlorines. There we go. That's how that one works. So as you go along, check to make sure that you're balancing on each side the reactants and the products. That's been the first page of the more problems. The second, or the third, I'm sorry, this is the second set of problems. The third set of problems is called harder problems. Let me go over some of those with you. They're done the same way, except that I didn't give you any parts of the answer, so you have to start completely from the beginning. So looking at the first problem, phosphorus, 1, there's no oxygen there, so I'll leave that blank. 2 oxygens here, divide the reactants from the products. 2 phosphorus, 5 oxygens. Okay, looking for something simple to balance, I see a 1 and a 2, but I also see this problem 5 and 2, an odd number trying to balance an even number. That's always a problem. And my hint to you for these is when you see odd totals trying to balance even totals, try to get the odd one to be even first, and then everything else will start falling into place. So for example, if you double an odd number, it becomes even. If I multiply that whole formula by 2, then that becomes 4, this becomes 10, and now I can see how I can balance a 2 and the 10 by multiplying by 5, because 5 times 2 makes 10. 4 over here, multiply by 4, and now it balances. 4 phosphorus on both sides, 10 oxygens on both sides. So when you get an answer in these problems, look at the coefficients that you used, 4, 5, and 2. On the flip side, there's an answer key. And look to see if you can find that set of coefficients. Here it is right here. It's not in the same order, it's scrambled. These are not in any particular order. So 4, 5, and 2 are used. You can always check to see if you used up a set of coefficients on the back. That way you know that you're on the right track. Let's look at the second one. In the second one, we've got 1 cobalt, 2 oxygens. Divide the reactants from the products. 2 cobalts, 3 oxygens. Look for something simple to balance. Uh-oh, we got another even odd. So remember the trick. Double the odd one, and it makes it even. And once you see the even numbers, you can balance those easily. I'll multiply by 3 on this side, and now I can multiply by 4 on this side. So what we're trying to do is get the same number of atoms of each element in the reactants and the products by changing these coefficients. 4, 3, and 2. Let's see if there's any of those on the back here. 4, 3, and 2. Here it is right here. 4, 3, and 2. Not the same order, but still the same set of numbers. So if I'm going really fast for you, remember this is a video. You can stop, rewind, slow down, listen to it again, go get some popcorn, come back, put it in your mix, set it to music, auto-tune me. I'd like to hear someone do that. That'd be pretty funny. All right, let's keep going. Third one. Got 1 nitrogen, 2 oxygens, no hydrogen, so I'll leave that blank. 2 hydrogens, 1 oxygen. Divide the reactants from the products. Hydrogen, nitrogen, oxygen, nitrogen, oxygen. Okay. Now let's look for things that are easy to fix. 2 and 1. That's easy to fix. So let's multiply by 2. And then everything gets multiplied by 2. And let's see what else can be fixed here. Let's see here. Now we've got 2 plus 1 is 3. 6 plus 1 is 7. And 2. Oh my. Well, let's see what we can do with this. This 2 plus 1 makes 3. Right there. I could balance that over here if I multiply this by 3. Now this becomes 3, and this becomes 6. Now 3 balances 3. 6 plus 1 is 7. 6 plus 1 is 7. Those balance, and the hydrogens balance. So that's how to do this one. You can look on the back to see if 3 and 2 are used as coefficients and cross those off. The next one, lithium oxide. We've got 2 lithiums, 2 oxygens. Carbon dioxide, 1 carbon, 2 oxygens. Divide the reactants from the products. Lithium is 2, carbon is 1, oxygen is 3, oxygen, the last one is 2. Okay. Look for something easy to fix. 2 and 2, well, nothing to fix there. 1 and 1. This adds up to 4, and that adds up to 5. Okay, so the only thing that we have to work with here is oxygen. Even number 4, odd number 5. To make this side even, we'll double the odd number. And see what else we can do now. Now this 2 doesn't balance this 1. So let's fix that by multiplying by 2. Now 2's balanced. That 4 doesn't balance that 2. So we'll multiply by 2. So that these 4's balance. And let's see what all works out now. 4 lithium on each side. A total of 4 oxygens. Plus 4 oxygens makes 8. A total of 6 plus 2 oxygens makes 8. 2 carbons, 2 carbons. Oops, it's the 2 there. Now this one balances. So look to see what numbers go up on the top, the coefficients, to multiply through each formula so that the number of atoms of each element are the same in the reactants and in the products. Look on the back to see if 2, 2, and 2 are used as a set of coefficients. Alright, the next one, sulfur is 1, oxygen is 2. And then this water has 2 hydrogens and 1 oxygen. Divide the reactants from the products. 2 hydrogens, a sulfur and 2 oxygens, and then 2 more oxygens. That's the starting count. Now let's see what else has to change. 1 sulfur on each side, that balances. 2 hydrogens on each side, that balances. So the only thing we have left to work with is the oxygens, which don't balance. We got a total of 3 in the reactants, an odd number, and 4 in the products, an even number. So there we are again with that same problem. So let's make this even by doubling it and see what happens to that. Okay, so now this 4 doesn't balance that 2. So we'll double this. Now the 4 is balanced, but this 2 doesn't balance that 1. So we'll fix that and see where that leaves us. 2 sulfurs on each side. A total of 6 oxygens in the reactants and 6 in the products. 4 hydrogens in the reactants, 4 hydrogens in the products. See how that little trick, when you've got an odd total, by doubling the odd one, making it even, unlocks the rest of the problem, making it much easier to solve. And by the way, if you go look around online for other instructional videos as to how you do this, you will not see anybody else using this same technique. You know why? Because this technique is genius, people. Genius. It works every time. You can learn how to do this. It's as simple as counting and multiplying by small numbers. Teach it to people when you get to college, because they will thank you for it. All right, let's do the last example on this page. Start by counting the calciums. Oops. Let's make that correctly, 1, and bromine 2. Sodium is 3, and phosphorus is 1. Divide the reactants from the products. 3 calciums, 2 phosphorus, sodium is 1, bromine is 1. Look for something easy to fix. 2's and 1's, 1's and 2's. Take your pick. Oh, we'll do the bromine first. 2 bromines on each side now, so that matches, but now that 3 and that 2 don't match. Maybe that wasn't the best thing to start with, because now it doesn't balance. This 1 and that 2 don't balance. Maybe I should have started there. Or this 3 and this 1, maybe I should have started there. Well, let's try this 2 and this 1 and see what happens. Alright, 2 and 1 balances. 6 and 2 doesn't balance. So maybe what I really should have done was something different. Maybe if I want 6 to balance over here, I should have, instead of using a 2, what if I'd used a 6? Now instead of having 1, I'd have 6. Okay. Now, but this 6 doesn't balance that 2 now, and that 3 doesn't balance that 1. But you probably noticed what you could do. Multiply by 3. Now it balances. 3, 3, 6, 6, 6, 6, 2, 2. My little trick about starting with the 1's and the 2's, you know, that's usually a pretty good rule of thumb. But sometimes you have to undo what you did or start from a different 1 and 2 to unlock the problem. Either way, you know when you got the problem right, because the same number of atoms will be in the reactants and the products. And just like I had to do it over again on this side, I had to cross out the 2 and I had to start back with my 1 and multiply by 6, and you know, that's okay to do. It's a balancing problem. When you balance things, they always start out kind of uneven. First you got to go this way, then you got to go that way, then this way, and then you get in the middle. That's what balancing is all about. So I did the front of each of those 2 sets of problems and left for you to do the back yourself. And if you have any additional questions, please bring them to class, bring them to school before first hour, or bring them to your lunch hour. I'm up here during all the lunch hours. Alrighty then.